Scale models and drawings are the real-life applications of using similar figures in everyday life. Let's start with the 2D version of this, a scale drawing. It is a proportional two-dimensional drawing of an object using a scale either to enlarge it or to shrink it. And that scale that you're using is called the scale factor. It's the ratio used to enlarge or reduce a figure. So two-dimensionally, this might be something like the state of Kentucky. That's the actual object, and we shrink it down proportionally so that it will fit on a map. Or think about some things in your science textbook. If you were studying an animal cell and you wanted to look at dimensions of it or see how things fit inside of it, an actual animal cell is way too small to look at. So what your textbook does is it enlarges it proportionally so that you can examine the things inside that animal cell. A scale model is the three-dimensional version of this. It's a proportional 3D model of an object. So this could be like an actual 2014 Camaro and comparing it to a Hot Wheel. Or it could be the toy tractors that my sons play with. There might be a 1/64th, a 1/32, a 1/16th model depending on the dimensions of it and how that compares to an actual tractor. So first let's examine how to find a scale factor. So here we have dimensions of a race car, and then we have the dimensions of a model of that race car. You can use the length or the height, either one, to find the scale factor. So I'm showing you how to do this with both dimensions, but you only have to have one of them. I've color-coded it to keep things straight. I'm putting the model length on top and the actual, the race car length on bottom. The model length is 11. The race car length is 132. That ratio, 11 to 132, reduces to 1/12. Likewise, for the height, the model's height is 5.5 inches, whereas the race car's height, the actual height, is 66 inches, and that also reduces to the ratio of 1/12. So to do this, the how-to would be to write a ratio comparing the model to the actual, which is what we did here, and then simplify those ratios. You want to have it reduce as much, and you can see here how I had to get rid of the decimal. And so it could be you multiply top and bottom by 2 and then reduce from there. Different ways that you could do that. If I were actually trying to pick which one, I would see that decimal on the heights and say, I'm probably going to go with the lengths because I don't have to deal with a decimal there. But it still could be done down here. You can also use a scale factor to find an unknown length. A photograph of the painting The Schoolmaster has dimensions of 5.4 centimeters and 4 centimeters. The scale factor is 1 to 15. So from this, find the size of the actual painting. So this is my thought bubble. What that scale factor communicates is that for every 1 unit on the photo is like 15 units on the painting. So down here, I compared the lengths. I used a proportion like we did in using similar figures to set that up. So 1/15 is the photo's dimensions on top over the painting. I know the photo's length is 5.4 centimeters, and what I'm wanting to know is the actual length. I cross-multiplied 5.4 times 15 and 1 times L, and so I figured out that the length is 81 centimeters. I did the same thing for the width. 1 is the dimension of the photo, 15 is the dimension of the painting, 4 centimeters is the width of the picture, and W is what representing what we don't know, the actual dimension, the actual width of the painting. Cross multiply, 4 times 15 is 60, W times 1 is W, so the width is 60. Put that together, the dimensions of the actual painting were 81 centimeters by 60 centimeters. Here are some opportunities for you to practice. For A and B, you are identifying the scale factor, and then for C, you're finding the actual distance on a map. For the scale factors, remember it's important that you put the model on top. So the model's dimension was 13. The dolphin's dimensions were 260. Reduce that, it goes down to 1/20. For part B, the model's inches were 6 inches. The actual wingspan of the eagle was 90. I divided by 2 first, and then I saw that that went down to 1/15. You may have saw already that they would divide by 6 and went straight to 1/15. Either way, you reduce down to 1/15. On part C, on a map of Virginia, the distance between Alexandria and Roanoke is 7.6 centimeters. The map scale is 1 centimeter to 80 kilometers. What is the actual distance between the two cities? So the ratio is comparing the map length to the actual. A lot of times I'll kind of draw that as a code for myself so I remember which numbers go on top of my ratios. So 2/80 is that ratio. And then it is 7.6 centimeters on the map. So I'm wanting to know the actual distance. Cross multiply to solve. 2x equals 80 times 7.6 is 608. Divide both sides by 2. And I get x equals 304 kilometers. Something that you might have done is you could have taken that scale of 2 centimeters equals 80 kilometers and said, well, then 1 centimeter equals 40 kilometers. And so you multiplied 40 times 7.6. That is also another way to do that.